In this lab, we're making a audio amplifier and a VU meter connected together, and so the VU meter is just like light, or like a light, or a bunch of LEDs in a series that like light up and pulse along with the audio that we're going to put into it. And then the audio amplifier just amplifies your input audio. So the way we do the audio amplifier is we run it through two different op amps. This first op amp will make it where you can design a gain of 1 to 10, so it'll increase your your input audio from 1 to 10, and then the second one just inverts it again so that it's not a negative output of the input. It's just a positive output of the input. So then that can mess with things, so that's why you do it that way. And then so the way we designed our potentiometer was we had a 22,000 maximum potentiometer, and we wanted the gain to go from 1 to 10, so we needed a 200 ohm resistor for the feedback resistance, so that its maximum would be 2,000, which is 200, or 2,000 divided by 200, and then its minimum would be 0, because you can make the potentiometer 0. And then the other potentiometer is just two of the same resistances. It doesn't matter which resistances you use. We used 1,000 ohm resistances, which is why we did those ones. And so if you use the same ones, then it just V out equals negative V in. So that's what we did with that.
Okay, now we're going to be talking about what's actually going to be lighting up our LEDs. The chip we're using is the LM3915N. This essentially is just a bunch of comparators cascaded in a certain way with a bunch of resistors. And first, I'll explain what a comparator is, and let's use this water analogy. Think of a water pump pushing water through a pipe, and think of the comparator as the gate. When the water flow is weak, the reservoir gets no water because it can't overcome the resistance of the gate. When the water flow is stronger than the resistance of the gate, the reservoir will fill with water. Now, if you think of adding multiple reservoirs with multiple gates, to fill the second reservoir, the water flow must be stronger than the resistance of both gates. Okay, now looking at our chip, we have a reference voltage that's coming in here that we're controlling with our potentiometer. This voltage is going to drop across all these resistors. Now we have a signal voltage coming in from our audio that's running through the buffer and running up, that's also connecting to these comparators. When the signal voltage reaches this point, say at this first comparator, if that signal voltage is greater than the voltage dropped across this resistor, that means there's a difference, and that's what the comparator responds to, is a difference in voltage. If the signal voltage is greater than the voltage across that resistor, then you can think of it as kicking out a ground, which is what we have here at port 2, which will link the positive supply from our chip down through the comparator and basically complete our circuit lighting up this diode. This is an important concept to remember because the diode only allows a flow in a certain direction, so it needs this side to be negative. Now, to light up the second one, you can think of it as the water analogy. To fill up the second reservoir, it has to overcome both the resistance of this gate and the resistance of this gate to fill up the second reservoir. So, this comparator will use both of these resistors and compare the signal voltage to the voltage dropped across both these resistors. This signal voltage has to be greater than the voltage across both of these series resistors to, you can think of it as completing the circuit again to ground.